Flipping on the back, you see these two postulates written out. And postulate is nothing but a fancy word for like a rule or a property or a law. But side, and we're just going to abbreviate it as SSS. Okay, just means that if three sides of one triangle are congruent or equal to the three sides of another triangle, then those two triangles are congruent. And likewise, we have side angle side, which is just SAS, as if two sides and the included angle, okay, and what I mean by that is that the angle is in between the two sides, not side, and we're talking about an angle over there, side angle. The angle is in between, just like the A is in between the two S's. It's side, angle, side. That's what included means. So two sides in the included angle of one triangle are equal to two sides and the included angle of another triangle. Then those two triangles are congruent. Okay, those are the big two things. I mean, if you want to circle and put a star, circle and put a star, those are really the two main points of this lesson. And so let's come down here at example 7. Are these two triangles congruent? Well, and we're going to prove it. And proving just allows us to be organized. It really helps us through these problems, especially as things get more complicated, to kind of organize our thoughts. So right now we're looking at DC is congruent to BC. Okay, those two things are congruent. How do we know that? The tick marks tell us. That's what these things are. We've said earlier that this one tick mark and that one tick mark mean those two things are the same. And so that was just given to us. You don't need to put tick marks, just put given. And then same thing, AD is congruent to AB. And again, that was given. And so we have two sides, but we need a third piece. And in all of these, we need three things. You got to have three. We got one, we got two. And that's a side and a side. So we needed either angle or a side. And so we kind of have to look and figure that out. But some of you maybe already see they share this side, like that example before. This side, AC, has got to be the same in both triangles. If we split it apart, DAC, and then be ACB. Okay, if we split these two triangles apart, well then AC is going to have to be the same as AC. It just makes sense. AC has got to be the same as AC. And why is that? It's just because they share it. And you just put share, that's fine. The technical name is the reflexive property. Just put they share it. That's good enough. And so now we have three things. We have a side, and a side. And so we have enough to now say that triangle ADC is congruent to, and I want to go in the same order. If I went ADC, I'm going to go ABC. And how do we know they're congruent? We know they're congruent because of side, side, side. Okay, pretty straightforward. Looking down at the next one, and we're going to get pretty good at reading all of these symbols. These little arrows mean that these two lines are parallel. And anytime you see parallel lines, and this is why we spent so much time on some of those basic concepts in Unit 1, is because you got to know them. But anytime that you see parallel lines, you need to automatically be thinking, okay, AI, SSI, and corresponding. If you're rusty on those, get out your notes from that unit and flip and look and make sure that you get those, or come in and make sure you're asking me questions on those things, because we got to know that stuff. But right off the bat, we see parallel lines. That's what we're thinking. Okay, just to have that in the back of your mind. But usually with proofs, with these kind of problems, it's best to just start out with what they give you. It just kind of gets you started and gets you off on the right foot. So right off bat, we know that MH is congruent to KJ. And we know that because it gave it to us. And that was a side. And then if you look at, again, if two triangles are together, they're sharing a side. HK is going to be the same as HK. They share that one. And so here we got two sides. And we know we need a third thing. And that's where we need to use the parallel lines. If these are parallel, and you can draw and extend it if you need to help you visualize, you have a transversal coming through right there. Maybe that makes it a little more complicated, I don't know. But two parallel lines and a transversal. So this angle right here and this angle are alternate interior. And we learned that alternate interior angles are equal. And so that's angle MHK is congruent to JKH. And we know they're congruent because AI. Okay, remember AI, Allen Iverson, they kind of cross over the line. Allen Iverson, AI is known for his crossover. Okay? But the key is knowing that AI angles are equal and not that they add up to 180. But anyway, now we've got a side, and an angle. Well, this is just the order we wrote it in. But if you look on our picture, you have side, angle, side. Side, angle, side. And so now we can say that triangle MHK is congruent to triangle, and we want to go in the same order, JKH. And we know that because of side, angle, side. Okay, try number 9 on your own. Hit pause on the video. Use what we learned in these two. Flip back over if you need to. Give it a shot on your own. Alright, so you should have gotten that AD is the same as DC. Given. The two angles are the same. And make sure you got the letters right. Because they're given. And then they share this line DB. So we got a side, angle, side. Side, angle, side. Which makes the two triangles congruent. Because the side, angle, side. Okay? And then the last example is something that's just a little different. Is what other information, what else would we need to prove that this triangle is congruent to that triangle? Now, right off the bat, you should see they share two things. And so right now we have a side and we have a side. And the two postulates that we learned are side, angle, side, and side, side, side. So we need either a side or we need either an angle. And if we had that, 2 is not enough. You always need 3. And we're going to learn a couple other ones tomorrow. But in any case, you always need 3 things. So we got 2. So we could either know, if we knew that RK was the same as ST, if we knew that, then we could do this by side, side, side. If they told us those things were the same, we could say yes, side, side, side. Or if we had this angle, if they told us those angles were the same, and again we got AI popping up, the crossover angles. If we knew that those angles were the same, or if we knew that these lines were parallel, if they told us RS were parallel to KT, well then we know that those angles are the same, and we could prove it using side, angle, side. Okay, that's it for the lesson. It's pretty brief. I know I only did kind of one of each, but you'll get a chance tomorrow to practice these ideas. And I think this stuff is kind of fun. We're getting into the good stuff where we're actually able to start using some of that basic stuff that maybe didn't seem to have any connection or anything. But hopefully you have fun with this tomorrow in class. Write down any questions you have and be ready to work hard tomorrow.